Welcome to the Chapter 5.2 lesson video. Today we're going to be talking about verifying identities. All right, so this is the big part of this chapter. Hopefully you memorized your fundamental identities from 5.1. That's going to be very, very useful. If you haven't, you should do so. Get that piece of paper out. It's going to be really helpful. Verifying identities is kind of like proofs mixed with algebra. There's some very specific rules you have to follow, and showing your work is key. This is something you can't cheat. This is something you really need to learn how to do. So taking the time to take good notes, ask good questions, and practice all these problems we're giving you guys is going to be very important. We're actually going to end up spending 2 days on this topic, so this one will be kind of repeating again next week in hopes that it'll help you guys practice a little bit more. But let's go ahead, let's get started, let's dive in. All right, so basically I can verify an identity. So we'll talk about what that means and what you have to do that. Yeah, let's get started. All right, so fundamental identities. So these were the identities that I asked you guys to memorize: the reciprocal identities, the quotient identities, the Pythagorean identities, and the negative angle identities. Really, we use these top 3 ones here. Reciprocal, you should already know. Quotient, tangent is sine over cosine. Cotangent is cosine over sine. And the Pythagorean ones come up a lot. Really, if you know the first one, you can kind of know the other ones, but memorizing all 3 of these Pythagorean ones is really important to you doing well this chapter. These are challenging topics. This is a harder chapter. It is not just you, I promise. Please, please, please take the time to make sure you do well by practicing, asking questions, and giving this the time it needs. All right, so verifying identity rules. There's kind of 3 rules you have to follow as you do these problems. And if you don't follow these rules, it's a critical failure in the problem. You can't get any points if you're not following these 3 rules. The 3 rules go like this. You can only work on one side at a time. Okay, so you can work on both sides of your equal sign. So that's what it means by sides, both sides of your equal side, but you can only do one side at a time. So that means that you can't do 2 sides at a time. Every time you do a step, it's one side at a time. Okay, the second rule, no moving stuff from one side of the equation to the other side of the equation. This is a really big thing. People try and like add something to one side or divide or multiply. Nope, that changes it too much. We can only simplify one side or simplify the other in order to try and make them match. And that's our goal here, is to make a match. And then each step you do must be reversible. So you can't do anything that's unreversible. You can't just make up crap. That's the biggest thing I see is people just, they get stuck, they get confused, and so they just start making something up on one side or the other. These are challenging problems. The more of them you do, the more patterns and stuff you're going to start to recognize, the better you're going to be at them. You're going to kind of learn these little tips and tricks and things. They're going to be really foreign at first, but the more you do, the less you're going to feel the need to just kind of make stuff up to make it work. Because that's really what people end up doing, is they just kind of make crap up to try and make it work, and that's not going to help you here. So let's keep going. Let's talk. So here are some strategies. Now, I don't expect you to try and jot these all down right now. Maybe make some little some bullet points of what I'm saying here, but here's some strategies to help you do these problems. Okay, so first of all, know your identities. Know your fundamental identities. That's going to be the biggest, most helpful thing. Have them memorized. Learn to recognize what different things look like, kind of what the kind of key features are. Is it Pythagorean? Does it have some squareds in it? Is it a fraction? Is it a quotient? Can you change cotangent to is it one of those ones, or is it a reciprocal? Is it something in a denominator you can move up to a numerator? There's lots of little clues and hints and tips that are going to help you out here. Okay, pick the more complicated side. Don't avoid the complicated side. Make it less complicated. That's always a good thing. Sometimes it helps to change all your trig functions to be in terms of sine and cosine. So tangent, cotangent, secant, cosecant, they can all be rewritten in terms of sine and cosine. So trying to condense things down so that way you only are working with 2 trig functions rather than 6 ends up being really helpful. All right, look for factoring. Now, this is something you'll see in a couple examples we do, and I'll try and point it out in class too. Things like difference of squares, perfect square trinomial, being really familiar with how things factor algebraically and not being intimidated by there being a sine or a cosine involved is going to be really helpful. All right, another thing you're going to want to be able to do is recognize this kind of pattern. This happens a lot. If you multiply 1 plus sine of something by 1 minus sine of something, what you end up with is 1 minus sine squared of that something. Well, 1 minus sine squared is something, that's a version of our Pythagorean. That's just cosine squared. of the something. So being able to recognize that that multiplication creates something and seeing that pattern and seeing it a couple times is going to be really helpful. Keep in mind, last tip, keep in mind what's on one side and what's on the other. If you have two terms on one side, how can you get it to become one term? If you have two fractions, if you have no fractions, how do you make the sides match? So if you have something that's like x plus y, and on this side you have just an x, how are you going to get a second term? Or if you have fractions on this side and no fractions on this side, how are you going to make fractions? Knowing what the two sides look like and how you can condense or expand them is really an important key to trying to get them to start matching. Okay, so these are kind of some tips and tricks. Really, the best way to pick these up and see them more and more is to start doing the problems. There's really, once you start doing them, there's only so many ways I can kind of put something new or tricky in there that you haven't seen before. And so getting the practice of seeing a bunch of examples, doing a bunch of examples, rewatching these videos is going to be really helpful to your success. All right, so we got a couple here. We'll start with these two, and we'll do them and take our time on them. And if you have questions, reach out to me and talk about them, and we'll talk about some in class as well. But let's go ahead and let's try a couple. I'll show you what to expect. I'll talk through my thought process as I do them, and hopefully it really helps you out. All right, so our first one here, we have cotangent of theta plus 1 equals cosecant of theta times cosine of theta plus sine of theta. So I'm going to rewrite it. So that's cotangent of theta plus 1 equals cosecant of theta times cosine of theta plus sine of theta. I like to draw a line down the problem to kind of distinguish my two sides so I don't accidentally try and move stuff between them. Now this one hopefully is an easier first example. We can do all of our algebra rules that we could do normally. And so when I see this, I see that this side on the left has two terms. This side has two terms inside of a parentheses and one on the outside. So my first instinct here is to distribute. Distributive property is a thing I can do, and I'm going to go ahead and do that. So I have on the left now, I have cosine times cosecant of theta plus cosecant of theta times sine of theta. And on the right, I still have that cotangent of theta plus 1, and I'm not changing it, so I'm going to leave it alone. All right, so I'm going to keep going on the left now. Cosine and cosecant, I'm going to use my reciprocal identities. I'm going to rewrite everything in terms of sine and cosine. So I have cosine of theta over cosecant reciprocated down. It's going to become a sine theta plus cosecant, that's going to become a 1 over sine theta times the sine theta, so I'll have a sine theta on top as well. Well, I can simplify each of these now as well. Cosine of theta, that is the quotient identity. So cosine over sine, that's going to become cotangent of theta, plus sine over sine, that's going to become just 1. And hey, would you look at that? Our sides match. And so I'm going to put a check mark on both sides to say, look, they match. And this is what your work will look like. I will look at each step. This chapter is really a pain for me to grade, but I look at each of your steps and I look at it like this. I look at it, I say, all right, they did nothing on this side. Let's see, on this side, they distributed. I can see that. They then did the reciprocal identities. I see that. And then they simplified it down using a quotient identity and an algebra property. Okay, I need to see these steps. If you just go from here to here, you're not going to get points. That's jumping too much. You need to show me how these things evolved. All right, let's keep going. So this next one looks a little bit different, a little more complicated. It isn't that much more complicated, but let's see what happens. So I have tangent squared x times 1 plus cotangent squared x equals 1 over 1 minus sine squared x. All right, so there's a couple things I'm going to change. I'm going to do some stuff on each side, but I'll do it separately, and so you'll kind of see each side evolve. So I have two kind of main things that are jumping out at me. The first thing I see jumping out at me is this 1 minus sine squared x. Now, I know to recognize that as part of my Pythagorean identity. So one of my Pythagorean identities is sine squared plus cosine squared equals 1. And if I subtract that sine squared over to this side, I get cosine cosine squared equals 1 minus sine squared. So when I see that 1 minus sine squared, I'm going to change it into a cosine squared. So I'll change this into a 1 over cosine squared x. And then because I know it's probably going to happen, because I'm kind of thinking ahead, I'm going to go ahead and move that up to the numerator and change it into a secant squared x, because I think that's where we're going to be going in a second. If I don't need that, that's fine. I can always undo it and erase it in a second. Now this side, very similar to that last problem, I'm going to distribute. So tangent squared x times 1 is tangent squared x, and tangent squared x times cotangent squared x, so I'll write that as tangent squared times cotangent squared. Well, cotangent is tangent's reciprocal, so this is really going to be tangent squared x plus tangent squared x over tangent squared x. And tangent over tangent is just going to be 1. So tangent squared over tangent squared is also 1. So I get tangent squared x plus 1. And that is another one of my Pythagorean identities. And I know that tangent squared plus 1 equals secant squared. So I'll rewrite this as secant squared x, and the two sides match. And so I have verified the identity. Now, what's going to happen when you guys start doing these problems is you'll start doing something and things just won't work. I encourage you, do not hesitate, do not be afraid to go back, restart the problem, undo what you did, erase it, redo it. That's really going to help you. Redo old problems that you struggled with before. Practice, practice, practice is really going to be your key to doing well this chapter. I got some more examples. Let's keep going. Okay, so here's 2 more. We'll go ahead and do the top one first. I have cosine of x over 1 minus sine of x equals 1 plus sine of x over cosine of x. All right, so we'll see what happens here. And hopefully, as you do this problem, you'll kind of see it evolve. This isn't one that I think a lot of people get right away, but we'll see what happens. So first thing I'm going to do is remember something that was in one of our tips. I see 1 minus sine, so I'm going to multiply that by 1 plus sine. And this is a trick you'll learn to recognize, and you'll see it the more often you do it. 1 plus sine x. 1 plus sine times 1 minus sine is going to become 1 minus sine squared x. And you do that because that's a version of the Pythagorean. We talked about that just a second ago. On top, I'm not going to distribute. I'm just going to leave it separate. 1 plus sine x times cosine x. The reason I'm leaving it separate because I know that 1 minus sine squared is about to become cosine squared. So I get 1 plus sine x times cosine x over cosine squared x. So on bottom, I have cosine, cosine, and on top, I have just cosine. So I can get rid of the cosine on top and the squared, leaving myself with 1 plus sine x over cosine x, which is my identity. So I can put my check. Okay, now that's not something you will always recognize right away. That's something that you probably wouldn't have recognized without me pointing it out. But now that we've done it, hopefully next time you come upon this situation, it'll be a little easier for you to recognize. All right, next problem. 1 minus sine squared x over cosine x equals cosine x. Now, hopefully you're starting to see some similarities. This 1 minus sine squared thing has popped up a couple times. So hopefully you see 1 minus sine squared and you go, aha, that's cosine squared x. I'm starting to recognize that over cosine x. And then cosine squared over cosine, I'm going to get rid of the cosine on bottom and the squared on top because that's cosine, cosine on top and 1 cosine on bottom, so it gets rid of them. If you want to see that kind of broken down, it's cosine x on top and cosine x on bottom, so we're able to get rid of 1 from top and bottom. So that leaves us with just cosine x, and the sides match. So we've verified this identity. All right, looks like I have one more example for you guys. We'll do plenty more in class. We're really spending 2 days on this. So this video is here for you to come back and watch it. But we're going to spend plenty of time. Let's keep going. Let's see where we go with this one. So this one is a little bit different, and we're going to talk about some strategies. So this one, we have tangent x minus cotangent x over sine x cosine x equals secant squared x minus cosecant squared x. Now, this is one of those times where when I look at this, and this is one of the tips, I notice that this right now is one fraction, one piece. This one is two terms separated by a subtraction and no fractions. So what I think I'm going to do is I'm going to distribute the division. Now, something a lot of people forget is you can't just divide one piece by the bottom and one piece by the bottom. You have to divide both pieces by the whole bottom. So I'm going to rewrite this as tangent x over sine x cosine x minus cotangent x over sine x cosine x. And hopefully what you see happened here is I now went from one term to two terms. Let's rewrite what we have. So tangent, we're going to rewrite what we have in terms of sine and cosine, So tangent is sine over cosine over sine cosine minus, here, let me erase a little bit of that extra little bit right there, minus cosine over sine cosine. All right, I'll multiply by the reciprocal. So I have sine over cosine times 1 over sine cosine minus cosine over sine times 1 over sine cosine. And I will cross off the signs from top and bottom. So I cross off the sine here. I'll cross off the cosine from top and bottom. I'm left with 1 over cosine cosine. So that's 1 over cosine squared. I kind of ran out of room, so I'm going to continue this over here. So that's 1 over cosine squared minus 1 over sine times sine. So that's 1 over sine squared. And then, alas, I need to reciprocate this back to the numerator. Cosine reciprocated is going to become secant squared of x minus sine reciprocated is going to become cosecant squared of x. Notice that a lot of the times here, I kind of dropped writing the x, got a little lazy. I'll go back and add that in. I should really do that every time. Don't be lazy like me. I'm just not taking the time to do something I should here. So I'll go back and add them in, all those x's that should have been there, there as well. And so, yeah, I've now got secant squared minus cosecant squared. This is technically on this left side over here, so I can kind of, so check, and secant squared minus cosecant squared was what I was trying to make it look like, so it matches. So I verified the identity. That is a longer problem. That took some time. I saw that there was only one piece and it needed to become two. That was the big piece. Once you did that, it's something that you should be more comfortable with as you do more of these problems. I really, really encourage you to get started, try the homework, ask questions, do the problems with us in class. Those are all going to be things that really, really help you out. If you want, please reach out to me. This is a harder topic. You really need to take the time to practice. If you don't, it's going to be a big struggle, this chapter for you. All right? All right, until our next live session, I hope you have a great day.